Welcome, amazing fans, into today's physics class. Now, let us solve this question on moment of a force. Okay, having understood the concept of moment, let us look at this question on the board. So if today is your first time of coming across me on this page, please, I want you to hit the like button, share, comment. If you have any question you want us to solve, write it in the comment section. Now, let us look at this question here. It says a uniform meter rule is balanced at its midpoint. A 40-gram mass is hung at the 20-centimeter mark. At what point should a 60-gram mass be hung to balance the rule? Remember, this we talk about what principal moment. And for us to attain equilibrium, so the principal moment is applied where we have the clockwise moment to be equal to the anti-clockwise moment. Now let's look at this now. From the question, we are told that what a uniform meter rule. So when we talk about uniform meter rule, we are talking about the length is what 100 centimeter. So when it is balanced at the midpoint, it means center part, that is half of 100 is 50. So which means this is 50, that is where it's balanced, and that is fulcrum. Now, this side is 0, okay? According to the question, we are told about a 40-gram mass is hung at the 20 centimeter mark. That means at a point where 20 centimeter is. That is from here to here, it should be 20. That means from here to here is 20, okay? That is 20 centimeters. So the 40-gram is what? Hung there, 40 gram. So the question now asks us, at what point should a 60-gram mass be hung to balance the meter rule? So we are looking at the distance now. So we distance from here to here, that the 60 meter or the 60-gram should be what? Hung. So just place the 60 anywhere. Just place it anywhere. Let's place it here. Place it here. We don't know. Let's say this is the 60. Now, the only thing that will make this body to be in equilibrium is that the distance here and the distance here will not be the same. Okay. Since from here to here, this is the fulcrum. From here to here. And the distance from here to here, we are going to know that we are going to take equilibrium at this point. So we need to know the distance from here. Because the turning effect is coming either this way. This one is turning this way. And while this one is turning this way. Okay. So now, from here to here, if here is 20, I already know that the center is for 50 centimeter. That is the center. So which means from here to here will be what? 30 centimeter. But we don't know what is from here to here. That's the distance we are looking for. But that is not the major distance where the body will be in equilibrium. But let's first of all call here x. So the line that is perpendicular to this line of action, this distance, is this x. So taking moment about this point. So we have clockwise moment. Remember, we have clockwise moment is equal to what? Anti-clockwise what? Moment. Now, what is the clockwise moment? This one now is coming this way. This is the clockwise. While this one now is going this way is the anti-clockwise. So which means we have 40 times 30 equal to 60 times what? X. So we can get our x now by dividing both sides by 60. Now let's divide both sides by 60. So we have x equal to what? 40 times 30 all over what? 60. So we can cancel out 30 here, 1, 30 here, 2. This one here, this here, that is 20. So x is equal to what? 20 centimeter. But this is not the point where the mass or this 60 gram should balance it. No. Now remember that from here to here is 50. And from here now to this point where 60 is hung is now 20. So which means balancing point now. Balancing point or balance point is equal to what? 50 plus what? 20. So which is what? 70 centimeter. So 70 centimeter is the answer. This is the point where this mass, 60 grams, should be hung so as to balance the system in equilibrium. So this is very easy. I hope you find this class very interesting. If that is true, help us to share this post to get a greater number of students on this platform. And also do well to subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.